Welcome everybody to Algebra 2 2.3 Linear Functions Part 2. So here we're going to be talking about point slope form, what to do when you have 2 points, and then applications and linear regression. So let's first start with the point slope form. To write a linear equation given the slope of the line m and a point that passes through it, x1, y1, so not necessarily the x-intercept or y-intercept, but any point, we use what we call the point slope formula. The point slope formula is as follows. Y minus y1 equals x times the, equals m times the quantity of x minus x1, where y1, x1 come from the ordered pair, and m is our slope. This y and this x, the normal y, normal x without the 1, just stay y and x. They don't modify in the slightest. What we're going to do is we're going to use this as a vehicle to get to slope-intercept form. So we plug in the point, we plug in the slope to point slope form, hence the name point slope, and we then use that to get slope-intercept form. So here we start off with a point and a slope, and we'll plug them in. So this will be our x1, this will be our y1, and this is our m as we have listed. So we leave y and x as y and x. So we have y minus 7 equals -4 times x minus a -1. Notice I do have two negatives here inside that parentheses. That's because one of them is from the formula, while the other one is from the x1 value of -1. So together those would make a positive 1. Now our first step here is to distribute. So we can distribute this -4, and we get y minus 7 equals -4x plus, so let me try that again, minus 4, because -4 times a positive 1. And now, because our goal is to get to slope-intercept form like I mentioned earlier, we're going to try and get y by itself. So we have to add 7 to both sides, and the 7 combines with the -4, but not with the -4x. And we get y equals -4x plus 3. And now we have this equation in slope-intercept form. And so this would have a slope of -4 and pass to the point -1, 7. Now I do want you to notice that the y value ended up being y minus 7, even though it started out as positive 7. And the x value, the x1, ended up being positive 1 here, even though it started out as -1. And that's because if we look at this formula, it's minus y1 and minus x1, so it appears in the formula as the opposites of what it actually is. On number 2, if we plug this into point slope form, this being x1 and this being y1, we end up getting y minus a -5 equals 2/3 times x minus a -6. So we have two negatives in a row here and here, so all of those turn to addition symbols. We distribute the 2/3 to x and we get 2/3 x. So on the left side it's y plus 5, 2/3 x, and then 2/3 times 6 is 4. Feel free to do that off to the side, like 2/3 times 6, 6/1, reduce by 3 and get 1 and 2. And get 4. Now from there, we'll subtract 5 from both sides and get y equals 2/3 x minus 1. Now, if you don't have the slope, but you have 2 points, you can find the slope. So the slope formula is m equals y2 minus y1 over x2 minus x1, and those come from two different points. So y1, x1, x1, y1 would be one point, and x2, y2 would be a separate point. Now we'll talk about finding those in the order of all that in just a moment as well. But what you do is after you find the slope using that formula, then you plug it into point slope formula. So then that's the y minus y1 equals m times the quantity of x minus x1 we used earlier. So we have to first find the slope, and then when we finally have the slope, we can use point slope formula, because that necessitates or requires point and slope. On number 3 here, when we're finding the slope, it doesn't matter whether we call this point x1, y1 or the other point x1, y1. Let's say I just start off calling the first one that, which will make the other one x2, y2. So as I find the slope, I would do 7 minus 1 over -3 minus a -6. Now it might be helpful to put these in parentheses, that way we can better see the points that were plugged in, and we can tell that this minus came from the formula, whereas this minus over here, or the negative, came from the point itself. So this would give us 6 over, adding those two negatives in a row, 3, which results in 2. Let's say we had swapped around what we called x1, y1, and x2, y2. If we had done that, all that would happen is we'd have 1 minus 7 on the top, and on the bottom we'd have negative 6 minus a negative 3. So on the top we get negative 6. On the bottom, as we add instead of subtract, we end up getting negative 3, which results in positive 2. So you get the same answer regardless. All that matters is that we have the y's on top, the x's on bottom, and then vertically you get a point. So 7, negative 3 both come from the same point, and 1, negative 6 come from the same point, and that's true for both of these fractions here. If you were to try to put 7 first and 1 first, you can't put that y with another x on the bottom first. You'd have to have matching x's and y's from the same point first and the same point second. Now that we have our slope, we need to use one of the points to find point-slope form and then from there turn it into slope-intercept form. So you might be wondering, well, which point do we use? And the answer is pick either one. Pick whichever one you think is going to be easier to work with. So I typically try to pick ones with smaller numbers, as well as ones that actually have negatives, believe it or not, because as we plug the negatives in, they become positives because we have 2 negatives in a row. So this one is slightly smaller than 3, 7, and so I'm going to pick that one here. Y minus 1 equals 2 times x minus a negative 6. So we have y minus 1 on the left, 2 times x is 2x, 2 negatives in a row make a positive, and 2 times 6 is 12. Now I add 1 to both sides and I get y equals 2x plus 13, and that is my answer in slope-intercept form. If you had picked this point instead and plugged that in, you'd get the same exact answer as long as your math is correct. Number 4 here, finding the slope. Once again, it doesn't really matter which point you call x1, y1, or x2, y2. So let's say I like to pick the bigger y to come first personally. So I have 8 minus a negative 2 on top. And then because I put this or that y first, I have to pick the x from the same point to put first. So negative 6 minus a negative 2. If you had picked negative 2 to go on top first, negative 2 would have had to come on the bottom first. So on the top we have 2 negatives in a row, same thing with the bottom. Top gives us 6, bottom gives us negative 4. This reduces to negative 3 over 2. I did that wrong, I apologize. It's not 6 on the top, which would make it not 3 on the top, but instead it is 10 on the top in the orange, and in the green it is 5 on the top. Now you might be wondering, Mr. Costly, you moved the negative from the bottom of the fraction to the top of the fraction from orange to green. Here's the truth. It doesn't matter whether you put the fraction on the bottom, the top, or out in front, because regardless, the fraction is negative wherever it is. Now as I pick one of my points, I'm going to pick the smaller one, which is negative 2, negative 2, and I get y minus a negative 2 is equal to negative 5 over 2, my slope, times the quantity of x minus a negative 2. 2 negatives in a row in 2 different places. Y plus 2 equals, as we distribute, negative 5 over 2x. Negative 5 over 2 times 2 is negative 5. Feel free to do that work off to the side and put 2 over 1 and cross-reduce if you'd like. I'm going to subtract 2 from both sides and get y equals negative 5 over 2x minus 7. And that'd be the answer. Moving on to number 5 here. I got these 2 points I'm going to find the slope of. So the bigger number of the y's is negative 5, so I like to pick that first, minus a negative 8, over the same x value from that comes from the same point as a y value. So 10, since I picked negative 5 first, minus 1. This results in, as we add, 3 over 9, which reduces to 1 over 3. I pick either point, so I'm going to pick this one because it's slightly smaller. And I have y minus a negative 8 is equal to 1/3 times x minus 1. Those two negatives make a positive, and I get y plus 8. 1/3 times x is 1/3 x, and 1/3 times negative 1 is negative 1/3. As I subtract 8, I notice I'm going to have to get common denominators. Negative 8 secretly over 1, so if I get common denominators there, it's going to be 3, which would make this negative 1/3 minus 24 over 3. That results in negative 25 over 3, so I have my final answer of y equals 1/3 x minus 25 over 3. If you'd like, you could call that negative 25 over 3, negative 8 1/3, or negative 8.3 repeating. Moving on to number 6 here, finding the slope between these 2 points. Now you notice the y values are the same. So whichever one I put first, it'll look identical either way. It's still going to be negative 3 minus a negative 3. So you might be wondering, well, what about the x values? What if we don't know which y value to put first? How do we know which x value to put first? And the answer is it actually won't matter when the tops are the same. And I'll tell you why in just a moment. So let's just say I put the negative 8 first in this case. So on the top, we have these 2 negatives in a row, and we get 0. On the bottom, we have those 2 negatives in a row, and we get negative 6. Now, 0 divided by negative 6, or 0 divided by a positive 6, which is what you'd get if you switch these two around, is the same answer regardless. It's 0. So our slope is 0. Now, as I pick a point, I'm going to pick negative 2, 3 because it's smaller. Y minus a negative 3 is equal to 0 times the quantity of x minus a negative 2. Change the signs, which you might automatically just start changing the signs as you plug it in and just plug it in as y plus 3 instead of y minus a negative 3. 0 times all of this will just be 0. We get 0x, which is 0, and we get plus 0, which is 0. So we get y plus 3 equals 0. If I subtract 3, I get y equals negative 3 as my answer. Now you may recall from our last lesson that when the slope is 0, it's a horizontal line. A little remembering from the z for the horizontal line for 0. And anytime we have a horizontal line, it's y equals a number because the y value is not changing. So here, if you notice this up here as slope is 0, you could automatically say, hey, those are the same as well. And so we have y equals our y value, and that'd be our answer. So you could shortcut through all of this if you catch that. If you don't catch that, no stressing at all. You can still get the answer as we did here. Let's do some applications. How exciting. So slope-intercept form. So we're going to set these equations up in slope-intercept form, and then we're going to solve. So we're going to set up on the left, and then we're going to solve for something on the right. So on the left here, a cab ride costs $4 plus $1.75 per mile driven. So we're going to write an equation to represent the cab fare and define our variables. So we're going to have two variables here, an x and a y like we have. So x and y. And x is going to be the variable that we're going to plug in, the variable that's going to be changing first and modifying another one, the independent variable. So the x here is going to be the number of miles that are driven, where y is going to be the cost of the cab ride, because depending on the number of miles, that'll change the cost. And so as we set up our equation here, y, the total cost, will equal $1.75 per mile, 1.75x, so per just kind of means that we're multiplying every single time, plus 4, because you start out paying 4 regardless. And we notice that this is y equals mx plus b. So on letter B here, if Clay's destination is 17 miles away and he has $30, will he make it? We plug in 17 for x, and we see how it compares to the number of 30. If it's less than 30, Clay will be just fine. He has enough money. If it's more than 30, Clay will not be fine. He would need to get more money to make that cab fare. So y equals 1.75 times, my iPad glitched out there big time. 1.75 times 17 plus 4. 1.75 times 17 is 29.75. And if we add those, we end up getting $33.75. So that cab fare would be $33.75. So Clay does not have enough money. The answer is no, he does not. Let's move on to the next page. Moving on to example 8 here, the Jones are purchasing a new home, and the closing costs are $249 plus 3% of the purchase price of the home. And similar to example 7, we'll set up our equation and define variables on the A part, and on the B part, we'll use that equation. So write an equation to represent the total closing costs and define variables. So we're told that we're supposed to represent the total closing costs. So that's going to be one of our variables there. And if you're given one of them as like a total number, it's typically going to be your y or your dependent variable. And that's because it depends on other things. In order for it to be the total, it has to come second or last or at the end. And that would mean it's dependent upon something else, whatever comes before it. And so the closing cost depends on the purchase price because it's 3% of the purchase price. So we could let X be the purchase price here. Now you could also call the purchase price P for purchase price, and then the total closing cost you could call T for total. Just be careful you don't make it look like a plus sign, so make sure to put like a tail there if you do that. Or you call like C for closing costs if you want. I just went ahead and called it X and Y. So then the equation would be Y for the total equals 3% of the closing costs. So 3% is 0.03. And then X for the closing costs plus $249 no matter what that are paid in addition to that. Now we're going to use that equation in part B, knowing that the purchase price of the home is $195,000 and the seller offers $5,000 closing cost assistance. Something that can happen in buying and selling houses is that sellers will sometimes pay part of or all of closing costs. So in this case, the sellers are paying for $5,000 of closing costs for the buyers. And so will this cover all of the closing costs? We're trying to figure out, is that enough money? And if not, how much will the Jones need to pay out of pocket to cover the difference? So what we need to do is we need to plug $195,000 into the equation for X, the purchase price. So we'll have Y equals 0.03 times 195,000 plus 249. And as we start solving this one, 3% of 195,000 is 58,500. Try that again, 5,850. I wrote the wrong number, but I said it incorrectly. And then we're going to add 249 to that. And that'll result in a total amount of closing costs being $6,099. So the question is, will that be enough? And the answer is no, it won't be. And so how much will need to be paid by the Jones to cover the difference? $1,000 and $1,099 will be the difference that the Jones will need to pay. Since the sellers are offering $5,000, we subtract that from the closing costs that would need to be paid, and we get the result of $1,099 that the Joneses will have to pay themselves. Number 9, a 22.5 ounce candle burns at a rate of once every 5 hours. So on A, we're writing the equation, defining variables, and on B, we're going to use the equation. So I'm going to once again do X and Y. And X will be the number of hours that this candle is burning, and Y is going to be the amount of the candle left. So I'll just put candle left. You could do T for time in hours, or you could do H for hours, and you could do C for candle left if you wanted, or O for ounces. Be careful if you do O for ounces, that doesn't look like a 0. And now this equation, it would be Y is the amount of candle left, and it's 22.5 is how much you start with. And if we're burning it, we're losing it, so we're subtracting it, and it's a rate of 1 ounce every 5 hours. So I'm going to put 1 over 5x hours. So 1 over 5x. And if you wanted to flip this around to where it's the mx and the b in order, you could do negative 1 over 5x plus 22.5 that the candle starts with. And either one of those is perfectly fine. How many hours will the candle last? So we're saying how long until the candle's gone? There's no candle left, so that means y would be 0 for this scenario. So we set y equal to 0, and we go ahead and start solving. And so let's just say I went ahead and set it up like this, like I had it originally, but if you did the other one, once again, it's completely fine as well. So I'm going to go ahead and move one of these two over and keep the other one where it's at. I'm going to move the negative one by adding 1/5. That way both my numbers are positive, because I just prefer working with positive numbers to try to keep that negativity out of our lives, you know. And I believe this was 22.5, but I actually wrote 22 in the problem there. So 22.5, I'll edit that. Now at this point, I have to multiply by the reciprocal to get x by itself, so I can multiply by 5 or 5/1 if you prefer. And that leaves us with x being 112.5. So this candle will last for 112 and a half hours. So some more applications, but this time we're going to have it in standard form. A quick reminder, standard form is ax plus by equals c. Now, Josh bought 3 bags of potting soil and 10 bags of mulch from Home Depot. Write an equation to represent the total cost and define your variables. So we don't know the cost of the potting soil and we don't know the cost of the mulch. So x will be the cost of the potting soil, and y would be the cost of the mulch. Now, neither here is really an independent or dependent variable. The cost of the mulch does not change based upon the cost of the soil, or vice versa. But what we do need is a dependent variable, and that would be the total cost that is paid, which I'm going to call C. You can call it Z just as easily, or any other variable you would like, such as T for total. You're also going to call the cost of the soil S, and the cost of the mulch M, for example. And so what this is 3 times whatever we paid for soil, X, plus 10 times whatever we paid for mulch, 10 bags of mulch at that price, would equal C, your total cost. So now, using this equation here, if Josh spent $40.91 and mulch costs $2.75 per bag, how much was a bag of potting soil? So we plug these in. So 49/1 is our C, 275 is our M, and now we solve for X. So we have 3X plus 10 times 275 equals 4091. So we go ahead and start solving this one by multiplying 10 times 2.75 and getting 3x plus 27.5 equals 4091. Subtracting 27.5 results in 3x equaling 13.41. And dividing by 3, we find that each bag of potting soil costs $4.47. Moving on to problem number 11 here. Kaylee has a collection of quarters and nickels, and we're supposed to write an equation to represent the total value of the coins, defining our variables. So we know how much a quarter is worth, it's 25 cents, but we don't know how many we have. So I'm going to call Q my quarters. You could also do like X, for example. And I'm going to call N my nickels, because even though we know the value of nickels, we don't know how many nickels there are. And once again, you call it Y. And then V is going to be our total value here. Notice that when we're doing standard form, we have 3 variables, compared to when we did slope-intercept form, we had 2 variables. That's a unique difference between the two types of problems here. So we can't just take the number of quarters plus the number of nickels and get the total value of the coins. Instead, we have to do 0.25 times the quarters for 25 cents for every quarter, and 0.05 times the number of nickels. I'm going to write a bigger 0.05 here. And that will give us the amount of the value of all the nickels and the value of all the quarters. And once we add those, we get V, the total value. So plugging some numbers in from part B, the total value of the coins is $5.50, and Kaylee has 17 quarters. How many nickels does she have? So we'd have 0.25 for the value of each quarter times 17 quarters, plus 0.05 times some unknown number of nickels equals $5.50 and change that Kaylee has. So we multiply 0.25 times 17, and we find out that Kaylee has $4.25 worth of quarters. Now here I did 0.05n instead of 0.05n. It's the identical thing. Whether you write that 0 before the decimal is completely optional. Subtracting 4.25 for the amount of the quarters, we end up getting 0.05n, or just 0.05n, equaling 1.25. And I normally actually leave off the 0.0 here, and I'm just going to go and erase it because it's kind of weird to me to see it written by myself, because once again, I just normally don't. But that's just a personal preference, whether you have it there or not. I'm going to divide by 0.05 the value of each nickel to get n by itself. And this tells us that n is equal to 25, which means Kaylee has 25 nickels. Number 12, the baseball concession stand sells soft pretzels for $4.50 and bags of popcorn for $3.25. Write an equation to represent the total sales from pretzels and popcorns on a given day and define your variables. This will be very similar to problem number 10, except for instead of potting soil and mulch, it's soft pretzels and popcorn. So I'm going to use, I'll use X for pretzels, and I'll use Y for popcorn. I could do like S for soft pretzels and B for bags of popcorn, but you can't really do P and P for pretzels and popcorn because that'd be the same variable. So X for pretzels, Y for popcorn here perhaps, and I'm going to do maybe S for the total amount of sales. So you could do M for the total amount of money, or P for proceeds, or just really anything you want, or Z because it's a common variable as well. And so this would be 4.5x, because $4.50 per pretzel, plus 3.25y, because $3.25 per bag of popcorn, is equal to S, the total sales from the concession stand. Now, if the concession stand sold 137 soft pretzels, so I'm going to do 4.5 times 137, how many bags of popcorn, so we don't know that, so I'm going to do plus 3.25y, would they need to sell to make at least $1,000? Now notice it says at least, so I'm going to do the at least tells us greater than or equal to, aka it could be the number on the right, or it can be more than the number on the right. And it would be 1,000. Now, if you did equals, I'll tell you what you could do at the end to still have the right answer worded the right way. So don't fret if you put equals here as well, or instead. So 4.5 times 137 pretzels means they made $616.50 off pretzels, which, holy cow, it's a lot of money off pretzels. Let's see, I wrote equals. Need to stay consistent there. Subtracting 615.5 from both sides, we get 3.25y is greater than or equal to 383.5. Dividing by 3.25, we get y is greater than or equal to 118. So that means that they need to sell at least 118 bags. So you could just write at least 118. Or the answer really is just 118. Because the way it's phrased, it says, how many bags would they need to sell to make at least $1,000? And the answer is, if they sell $118, or 118 bags, they make at least 1,000. So that's the minimum. So whether you phrase it as greater than or equal to, or just equal to, it really ends up getting the same answer on this problem, because it's saying that the minimum number they would need to hit that threshold of $1,000. Moving on here, let's talk about scatter plots. So a scatter plot shows the relationship between two variables. And we're going to sketch the three possible correlations below, or the three possible relationships. So in each of these, we'll have a graph, and I'm showing quadrant 1 in each of these graphs, which is the top right quadrant. And so a positive correlation means that both variables are increasing about the same time. And notice these are just a bunch of dots all over the place. So both variables are increasing at the same time. So as this variable increases along this axis, so does this one. And as this variable decreases, so does this one. So the variables have the same movement at the same times. A negative correlation is the same idea as they move together. However, they move in opposite directions. So as one variable gets bigger over here, the other variable gets smaller, goes lower, and vice versa. As the y-axis gets bigger, the x-axis gets smaller. So the variable, as one increases, the other decreases. That would be similar to like the amount of miles you drive and the amount of gas in your car. As the miles go up, the gas goes down. No correlation, so they don't really have any relation at all. They're just kind of all over the place, and it's a big old mess. Now, not every scatter plot will be this cut and dry, to where you can tell, oh, this is easily where they increase at the same time, or this is easily where one increases and one decreases. And this is very easily a big old mess. And so we actually have methods that we can mathematically see how well something's correlated, what type of correlation it might be, and how once again how well or how strong that correlation is. And that would be for another day. For now, we're instead just going to try to find a line of best fit. So given if you have a positive or negative correlation, which is what we'll be having for all of our problems in this lesson, we can make a prediction equation, aka a line of best fit. So it's not an exact line, a linear line, but it's an approximate line. And it can be used to predict the value of a variable given the value of the other variable. So it's trying to guess or predict with some level of accuracy what one variable would be if you know another. So this table to the left shows the relationship between the depth d of the lake in feet and the water temperature T in degrees Fahrenheit. And it asks us to make a scatter plot. So I'm going to be plotting D and T, and I'll put T, the temperature, on this axis, and D, the depth, on the x-axis, because this is on the left, this is on the right, and what the one on the left is typically what we call the independent variable, and the one that runs along the x-axis. Now, the D, I can go ahead and I'm just going to increase these by 2 so I have enough room. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and I notice it maxes out at 15, so I already have enough. If you had gone 1 through 15, that would also work there as well, just so you know. I just happen to go by 2s here. I think it might display it a little bit more friendly, but once again, if you went by 1s there and went 1 through 15, that's perfectly fine. Do like 1, 2, 3, 4, 5, so on and so forth. It really doesn't matter too much as long as you're consistent in whatever you do. You can go by 3s or 4s for all I care. Now, for the T values, they get really high really fast. And so what we could do is go by like 5s or even go by 10s. But if we do that, then these are all going to be very scrunched together. So it would benefit us, since those are all very close together. They're only 9 apart from the biggest to the smallest, where these are 15 apart, a little more spread out. It would benefit us to have a smaller scale of it increasing by perhaps 1s or 2s. Maybe 2s since we did that down here. But there's not enough space to go all the way from 0 up to 85 by 2s on this y-axis. What we can do is we can do like a bit of a break in the graph where you go just do that little some zigzags there, and that shows a break, and we can start from 0 and then go up to whatever number we want to start at. So let's say I just start at 70, and whatever number I start at from there, I can go by my interval beginning on. So let's say I go by 2s and I have 72, 74, 76, 78, 80, 82, 84, 86, 88, and 90. And I could have stopped clear at 86 because my highest x or T value would be below that. So once again, if you do this break here, we could really pick back up at whatever number we wanted. So we could have picked back up at 74 if we wanted. Now we're going to go ahead and plot these points. So 0, 85. So 0 left and right, 85 up and down. 4, 82, so 4 to the right, 82 up. 7 to the right, 81 up. 10, 79, so 10 to the right, 79 up. 12, 77. And last but not least, 15, 76. So as you can see, this isn't a perfect line here, but we can definitely see that they somewhat follow this line. And so to find our line of best fit by hand, what we do is we use two ordered pairs to write a line of best fit. And so I'm going to pick two ordered pairs that might be easier to work with using slope. And so we're going to use slope and then plug a point in using point slope form like we did earlier in the lesson. So if I'm going to use slope, I want, once again, points that are easier to work with. So I might choose the x values or the d values of 0 and 15 here, 0 and 10 here maybe, because then we're going to get a difference of 10. And we know that the x values, or in this case the d values, go on the bottom of our fraction, and so we're going to have something divided by 10, and that tends to work out a little bit better than some of these other numbers that we might divide by. Now, once again, if you picked two other points, that'd be okay here as well. Your result would just get slightly different. Be slightly different than mine. But if you show your work, that'd be okay. So I'm going to use 0, 85. I'm going to show what point I'm using. I'm going to use 10, 79. Once again, show the point I'm using. And I'm going to start finding slope with these 2 points. So I'm going to use m equals 85 minus 79 over 0 minus 10. And if you put 79 minus 85 on the top, that's okay as well. On the bottom, obviously on the top we get 6, on the bottom we get negative 10. And that reduces to negative 3 over 5, where the negative can be on the top, bottom, or out in front. So now I'm going to pick one of these points and use it to plug in using point slope form. I'm going to pick the one with the 0, because 0 is a nice number to work with. So I got y minus 85 equals negative 3 over 5 times x minus 0. Well, as I go ahead and distribute my negative 3/5 x, I get y minus 85 equals negative 3/5 times x. And negative 3/5 times 0 is just 0, and I don't have to write plus 0 or minus 0. And so now I add 85 to both sides, and I get y equals negative 3/5 x plus 85 as my line. And so that would be an approximate of this, saying you start at 85 and you go down 3 for every 5 you go over, or you go down 6 for every 10 you go over. Because remember, 6 over 10 is what reduced to 3 over 5. And so if I did that here and I started at 85 like it starts with up there, and I went ahead and graphed this, let's say I went down the 6 and over 10, we get to this point. And if I did that again, down 6 and over 10, we get these 3 points. And as we can see, all of the dots, all of these points here, all these orange dots, are either on the line or quite close to it. And so this ends up being a pretty good approximation to see what's going on. Not perfect, but pretty good. So we're going to predict the temperature of the lake at 25 feet of depth. So way over here. And so what we do is we plug 25 in for x into this equation. And once again, this won't be a perfect prediction, but it's a pretty close prediction based upon the data we've seen. If things stay consistent, it'll be pretty close. So now here, I'm going to multiply negative 3/5 times 25, and I'm just going to put that 25 over 1 and look to reduce and make this 1 and 5. And get y equals negative 15 plus 85, as I'm at 85 up here. I didn't write very well, apparently. And that means y would equal 70. So it would be 70 degrees Fahrenheit, approximately. We're saying it should be that, at least. Now, another method to find the line of best fit is called linear regression, and this can be done through a graphing calculator, which is super handy. It does all the work for you if you just type in the data points from the tables. and it ends up being the most precise equation possible. And how you do that is you enter your data, and then you use a different setting on a calculator to find the line of best fit. So as it mentions here, you had to hit stat, which is a button on this calculator. So this TI-84, very similar to the ones that we use. This is just an older version of the ones we use. And so there's this button for stat right there in the calculator. And so you'd click that button, and then you click enter. And you would first hit stat, and it would go to this edit screen, and the first option allows you to edit into a table, and then you enter all of your x values in, or your first table in, or the first side of the table into the L1, and then you enter all your y values into Y2 using the arrows to navigate from the L1 to L2, and L1 and L2 just stands for list 1 and list 2. And once you've done that, we'll then find the line of best fit by once again hitting stat after you typed all of them in. Then we'll arrow over to calc, so we can see this top menu again where it goes edit calc tests. And we'll arrow over from edit to calc by using this right arrow over here. And once we do that, we're going to go down to this fourth option where it says linear regression ax plus b. And that linear regression ax plus b just means y equals mx plus b, but instead of m, it's using a. And you can either arrow down and then enter, or once you're in this menu, you can hit the number 4 and it automatically does the fourth option. And once you do that, you'll hit enter. It might make you hit enter twice, but we shouldn't need to adjust anything on those menu screens. You'll see options to adjust like which list you're using, but it should default to list 1 and list 2. And if it doesn't, you can just ask me during a test or anything like that and do that. I'll go over how to do it on the iPad on Calc 84 as well just during this video. So let's go over some examples here. So this table below on number 1 shows the number of people, P, and suitcases, S, on an airplane. So P would be our independent variable, and S would depend on P. Here, the number of suitcases would depend on the number of people. So to find the regression equation, we're going to type all of these into our Calc 84. And so going over to Calc 84 here, I'm going to go to stat. And we notice stat is above the number 8 like we talked about earlier on the TI-84. And I go to stat and I'm going to go to edit. And I notice I already have these typed in here, but if I didn't, I would just use 63, hit enter, and it automatically takes my next one. I hit 115, hit enter, and I can use these arrows over here that you can see moving to navigate from L1 to L2 and start doing it in that. Now, if you're using Calc 84, you have to very specifically get out of this menu before hitting stat again. But if you're using the in the physical graphing calculators for the TI-84s like we use in class, then you don't have to worry about getting out of the menu before hitting stat again. So I would hit either second quit, or I can hit this X next to the upgrade at the top right. So I'm going to hit second quit here, and it gets me out of that menu. And then I'll hit stat again, go over to calc. Do that fourth here's the third option, linear regression ax plus b, but on the TI-84 it's the fourth option like we discussed. And it's asked me to put my list name here, so on this I have to enter my list name, and we have to go to second, and above 1 is L1 in the same color, and then we have a comma which is above the 7, and then second, and above number 2 is L2, and we can just go and hit enter there. And it tells me my A, which is really M, and it tells my B, which is once again the B. And we can ignore the R and R squared for our purposes here. So I'm going to round off the A and the B, because those are obnoxious decimals that I just don't need all of them. I'm going to round them to 2 decimal places. 2 decimal places. And as I round them to 2 decimal places, I get Y equals MX plus B, or AX plus B. 1.83x minus 16.50, the 9 on the 16.497 rounds up to 10, which would make the 9 round up to 50, or just 16.5. And so that would be our linear regression equation. And now we're supposed to predict the number of suitcases on an airplane with 500 people. So we just take 500 and plug that in for x. Or here it said P and S. So I guess I really technically should be using S and P, but if you change your variables to X and Y out of habit, I'm not going to do anything about that. I'm going to be perfectly fine with it, just like I obviously did here. So Y, the suitcases, would equal 1.83 times 500 for the people minus 16.5. Once again, Y is really S and X is P, but I just reverted out of habit without even noticing I did it. So 1.83 times 500 would give us 800 and it's subtracting 16.5 would give us 898.5. And so that would be all of this over here would result in that. And so the number of suitcases, I'm going to predict that since we can't have half a suitcase, that there will be approximately or about 899 suitcases. That would be my approximation based upon what we see, rounding to the nearest whole number in this case. And you could, if you wanted to, instead of writing about, you could do approximately or the approximately symbol, which is the squiggly equal signs, kind of like the Spanish tilde, but two of them. Moving on to number 2, so we're going to type in the population in thousands during certain years since 2000. And so it says since 2000, so 0 would be the year 2000, 3 would be 2003, 2006, so on and so forth. And we have our population in thousands, so this is 10.7 thousand, 11.1 thousand, so on and so forth. And so we're going to type these in once again to our calculator, and I'll just do it on Calc 84. And so what I do is I go over to Stat, I go to Edit, and I go to this list, and I have to clear out what's there. And to do that, I highlight L1, and I hit Clear, and then I hit Enter. Well, that's how we do it on the graphing calculator, but apparently that doesn't work on Calc 84. But on the graphing calculator, the TI-84s, you would do Clear, then Enter. All of this told me press Delete to clear list, so I'll hit the Delete button once I find that button. I'm not finding that button, but it's probably pretty obvious where it's at, and I'm just missing it. So I'm just going to go through and clear each of these individually. If it lets me. It will not let me. Delightful. Oh, this is the delete button. Okay, it doesn't say delete, but it is the normal looking delete button. So I'm going to go ahead and delete. Once again, on Calc 80, on the actual calculators that we use in class, you can just highlight L1, hit clear, and hit enter, and it clears out the whole list. So then typing in these X values here, or the years, it'd be 0, 3, 6, 9, 12, and 15. So multiples of 3 going up to 15. And clearing out L2, much speedier once I knew which button to push. 10.7, 11.1, and by the way, the order for these does in fact matter, so be careful about that. 11.9, enter. 12.5, enter. 13.2, and last but not least, 13.6. And so now I'm going to go ahead and quit out of this menu. Once again, on the TI-84s, you don't have to do that, but on Calc 84 you do. Hit Stat, go to Calc, go to my option for linear regression, and I have to type in my list. Once again, on the TI-84s, it should already be done for you. And now I find my A, or my slope, to be 0.203, which is going to round to 0.20, and my B to round to 10.64. So writing this down as my slope and y-intercept, find the regression equation. That'll be y equals 2x plus 10.64. Predicting the population of 2025, that'd be 25 years after 2000. So that'd be x is 25, for example. So that'd be y equals 0.2 times 25 plus 10.64. So we'd end up getting, after we do all of this math, 15.64. So the population would be approximately 15.64 thousand, or multiplying this number by 1,000, 15,640 people. Once again, 15,640 people approximately. Number 3, the table below shows the salary in millions made by the highest paid Major League Baseball player during certain years. And so here it lists the actual year, whereas above it said years since 2000 and listed like 0, 3, 6, 9. And we're actually going to change this to be more like it was on example 2, where we're going to call this 0, and we're going to call it years since 1985. So this would be 6 years after, this should be 8 years after, 11 years after, 13 years after, just taking all these minus 1985, and this would be 16 years after. And so those are actually going to be my x values. I'm going to type these x and y values in now to my list. So I go back to Calc 84 here, let it load, go to Stat, Edit, and clear out my list here, and start typing in. And so I have 0 for my x value, 6, 8, 11, 13, and 16. And my y values, I have 2.1, 3.8, 6.2, 9.3, 14.9, and 22. I have to clear out of here on Calc 84, but on the TI-84s you don't. Go over Stat, Calc, Linear Regression, make sure my lists are good, which once again on TI-84s you don't need to, but on Calc 84 you do. And I have my slope, or my A, as 1.22, and my B as negative 1.29. So taking note of that and writing these down over here. Y equals 1.22x minus 1.29. And now predicting the salary of the highest paid player in 2020, we'd make x whatever the number of years after 1985 is 2020, and so we do 2020 minus 1985, and x would be 35. So here, as we plug this in, we get y equals 1.22 times 35 minus 1.29. This results in 41.41, and that's in millions of dollars. It says salary in millions. So the highest paid player in 2020 would make approximately 41.41 million, according to this. And you could write this out as 41,410,000, which would be $41,410,000 as well. It would be the same number, just written more expanded. The table below shows the mileage M on 6 cars that were recently traded in along with their value V. So we have all these different numbers here, and we can just type in these numbers as we see them. We technically could have done it here with the years as well, but we just saved ourselves writing some bigger numbers by doing that. But these are pretty far apart, and they would be crazy numbers anyway, rather than getting simpler numbers like we did above with like 0, 6, and 8. So we're just going to type in the numbers we see here. So Calc 84 needed to load again. I'm going to clear my lists. And I'm going to start typing these in. So for my M, or my X values here, it's 5824, 25,824, 58,126, 73,005, 105,092, 159,062, and I go over to my L2 and type in the V, or the value, 16,920, 10,300, 7,225, 5,300, 3,125, and last but not least, 1,800. So I get out of here, I go over to Stat, Calc, Linear Regression, I have to put in my list. Once again, on TI-84s, you don't need to do this because it's done for you. And we're told the slope is negative 0.09, and the y-intercept, or b, is 13,888.67. So that would be 0.09x plus 13,888.67. So now predicting the value of a car with that number of miles, 13,258, we plugged it in for x, which is really m, and v is really y. So if you wanted to make m and v, keep it like how it started, or change it to x and y, it's fine. So y equals negative 0.09 times 13,258 plus 13,888.67. Doing all of the math over here on this side, I'm gonna fix my 09 there. I get the number 12,695.45, and that's $12,695.45 is my answer. And that is it for section 2.3, which was the linear equations, linear functions, part 1.